Good afternoon, everyone. Welcome to the last session. I'm Mark Harrower. I'm a guy who works at Esri, and my job title is rather broad. I work with a lot of different teams across the company, sort of as a catalyst, as someone who's trying to push things forward and be innovative in visualization and mapping and how we represent data and how we work with data, and really trying to sort of be innovative is kind of my role. If you don't know Esri, we're folks who make GIS, Geographic Information Systems, a very large company. We're in many countries around the world. It's the kind of software that powers the world. The modern world is very much run by GIS. It's one of those things that a lot of people outside of our community don't really know that and don't appreciate the central role that it plays. And so one of the things that's been great for me in joining the Esri team about 2.5 years ago was realizing what an influence that we have. And so when we come up with a new way of asking a question or of representing data or allowing people to generate answers visually or numerically, you get really a huge impact right away because you have millions of users using your software. And so the theme for today is how do the tools and techniques that we build influence the way people work? And one of the things that I think is really important for anyone who works with data is to think about the relationship that you have between the tools that you use to interrogate that data and the types of answers that those tools allow you to generate or don't allow you to generate. And I have long held the belief that there are ways in which we shape our expectations of the sort of questions that we ought to be asking to fit the capabilities of the technology of the day. So if you don't have an electron microscope because it hasn't yet been invented, you don't ask those kinds of questions. If you don't have tools that can handle large and messy data, if you don't have tools that can handle all sorts of the complexities of the real world, you shape the questions that you ask to fit the tools that you have at your disposal. And so it's really important, I think, especially when we're talking about data visualization and generating insights into complex processes, geographic processes, social processes, that we understand the way in which the tools that we have and the techniques that we apply to the data shape not only the questions that we ask, but the answers we generate and how certain we are of those answers. And so I've got some examples in the talk, but that's really kind of the larger theme that I want to ground this in. More specifically, what I'm going to be talking about today is some ongoing work, 2 projects in particular, smart mapping and a project called Insights, which is not yet public, but I've been involved with. Some of the common problems that aren't just specific to Esri. Anyone who works with geographic data, anyone largely who works with data in general is going to run into some of these problems and some of the solutions that we've been coming up with. Major theme in my work over the last 15 years has been the democratization of data visualization and specifically geographic visualization and cartography. These are fields that very much resided in the hands of experts for many years and were very comfortably a thing that you had to go and get a degree in to do well. And one of the things that we're seeing now is this sort of self-service model. You're seeing a lot of folks say, look, I already have a full-time job doing something else. I'm already an expert economist. I'm already an expert geologist, or I work in humanitarian relief. I don't have time to go and do an undergraduate degree and probably a master's degree in GIS before I can start doing GIS. Surely your tools could be a little more accessible than that. Remember, we used to have people who did full-time typing for us, and then we got word processing, and suddenly now everyone can do word processing. We're seeing this trend in many areas. Remember, there used to be travel agents who used to book your plane ticket for you. You don't need them anymore. I mean, you can, they still exist, but the vast majority of us are able to do this work ourselves. And so what is the equivalent breakthroughs that we can create? One of the earliest projects that I was involved with was something called Color Brewer, colorbrewer.org, which we came out with 16 years ago. And we gave away a lot of work, a lot of intellectual property for free. And at the time, people thought we were crazy. They said, you should be selling this to a company. This is stuff you could make money off of this. It ends up, what's happened is by giving away knowledge and giving away know-how, you end up having a much larger impact, and you end up being used by millions and millions of people, and you end up becoming kind of the standard that everyone uses. And so locking things up behind passwords, locking things up behind a price tag is often not the best way to influence a conversation. And so that was a fun project. And there have been many other things, but this idea of empowering people who are already smart and good at something else to do their own work. How many of you tweet or have a blog or do some form of self-publishing? A couple of you. You don't need to hire people anymore to do that for you. You don't need a press department. You don't need typesetters. You don't need a publishing company. You can just do this yourself. And so with smart mapping, that was really the theme of it. We wanted to enable people to make brilliant maps quickly and with confidence. And that last part is really important. How many of you have ever used something like GIS or some software, say statistical software, and you get an answer but you're not really sure if it was the right answer. It worked, the software didn't crash, but I don't have any confidence in that answer, and I'm not sure if this is really something I should go to my boss with and say, look, there's an 80% correlation here, and I'm convinced we have to do something, right? And so if you don't have a background in this, just knowing how to push the buttons isn't enough, because you'll get answers, but you don't know whether they're answers you should really trust. And so that with confidence is really important. And basically, for me, it's a combination of technology that collaborates with you and partners with you, but can also educate you as you go, so that you may not have the expertise to know what some spatial analysis technique is, but there's a whole wealth of information behind this, and there's people with PhDs behind this who can vouch for these techniques and who can explain when and when you shouldn't use them. Even better, technology that knows itself when it's appropriate and when it's inappropriate to use certain, for example, spatial operators. We really want to simplify the map authoring experience. Absolutely no one likes clicking 50 times when you could click 3 times, right? That's a win for everyone. So what is the simplest path? And that's one of the questions that I've been asking to really help the teams at Esri clarify their work. If your product could only do 3 things, what should those 3 things be? Asking a question that forces clarity like that is really great for software. It's really great for the teams that work on this, because they think they're paid to build features, and there's been a shift with the app revolution to building clarity. That's what people are paid to do. They want it just to work. Heck, if it comes with 1 button, I'll be delighted as long as it does the one thing I need. Data-driven workflows. This is something I'm really, really passionate about and could really nerd out about for a long time. The idea is that the thing that you're doing, this task in front of you, should be aware of the data that you're working with so that you're offered the right tools at the right time. How many of you have ever experienced software where you're given 300 tools and 300 choices, but really only about 3 of them are appropriate for what you're trying to do, but you don't know which one? Some of them are grayed out, some of them aren't. You're not really sure. You kind of go down every menu and you're like, is that what I need? Should I be doing this? Do I know what I don't know what this thing is. I've never even heard of it, but it's not grayed out, so apparently it's appropriate. This is where people hang themselves with software, because they don't know better and they're trusting the software as allowing them to do everything. And so what I've been pushing with smart mapping and with other projects at Esri, can you eliminate the stupid choices for me? Can you put the expertise into the DNA of the software so that if I'm working with categorical point data, you're not offering me something like isoline mapping, because that's just not appropriate. Now, if you have a degree in this stuff, you know that's not appropriate, but if you don't, you might be tempted to do that. And so we really want to make sure that the data is driving the UI. This is a departure also for those of us who think about UI and UX. The interface is going to change constantly. The next thing you click on changes the next sequence of choices. It's this iterative process. I like to think of it as a conversation between the technology and the work that you're doing. So if you're at this point in your workflow, these are the next 3 logical steps that you could take, and we think these are appropriate. We're not trying to disempower people, we're just trying to remove the stupid choices that no one should be clicking on. We want to bake expertise in the tools. Some of the great examples we've seen today are wonderful, but you would really need someone to walk you through them. And this is true of a lot of work where the end result is totally transparent and really powerful, but the steps involved to get to there are really, really hard and involve a lot of kind of manual work that you may not know how to do. So can we build expertise into our tools so, again, that you have confidence? And this really boils down to this question: how much of the map-making process, since we're a mapping company, how much of the map-making process can we automate? And the answer is a surprising amount. And I've been working on this for about 2 years, and it's incredible how much, and I'll give you some examples of this in just a second, how much of the map-making process can actually be reduced to a set of formalizable logic that can be built into an interface. You don't even know it's doing anything, it's just sort of magically working. And how much about your data can we infer at author time? So when you say, I want to work with this data, we can analyze it very quickly the moment we see it and understand some of the limitations around that data. Maybe it's based on the size of the data. For example, should you be running correlation if you only have 10 points? It's probably not statistically robust, is it? You need much larger samples. And so looking at things like the size of the data, level of measurement, precision, the geographic distribution, there are a number of ways in which we can analyze the data to help you along. We really want to offload work from the computer, from the human to the computer. And let me give you an example of this where people always, it's funny, people are often offended by that statement. They're like, but I'm paid to do this stuff, and I know this stuff, and this is my expertise, and this is like a domain I feel comfortable in. But I think the vast majority of us just like technology that works with us and just does things. Great example is typing on my smartphone. I don't know about you guys, but I'm probably about 50% accurate with my big fat thumbs when I'm typing a text message. But if you notice, the workflow in your smartphone no longer says, there are errors in your text, period. And then I have to go and find something called spell check, and then I have to run spell check on my message before I send it. It just collaborates with me, and as I'm typing, it's intuiting my intent. It's not perfect, but it's really good. Any technology which can intuit your intent is an exceptionally powerful thing, because it's becoming a collaborator and it's not becoming clippy. Any of you remember Clippy from Word that pops up and says, hey Mark, it looks like you're trying to type a resume. No, I'm really not, but thank you for getting in my way and slowing me down. Instead, what I do is I now type at a ridiculously fast pace, only about 50% accurate, reasonably confident that almost everything is going to be fine. And so this is what I mean by offloading and by collaborating with technology. So not technology that gets in the way, but technology that can help. Let me give you some examples here. Automating visible range. Great thing about digital maps, you can zoom in and out of them. One of the problems is everyone assumes because it's digital, you need to zoom in and out. Footnote, you really don't. If the map makes sense at one scale, get rid of the zoom buttons. Honestly, it's just digital candy. It doesn't do you any good. I know you feel like you need it, you don't. Second, maps allow you to zoom in and zoom out. Here's the question. No software you've ever worked with has ever said to you, you're zooming in too far, you're going to lose the reader, you're going to make them confused if you zoom in this far. You're letting them zoom out too far. Let me give you an example. I have 5 potential locations for a new Starbucks here on the Upper West Side. Why should I make a map that lets me zoom out to see New Zealand? In what world does that actually help me make a decision about citing where one of those next Starbucks should go? The defaults for software is they'll let you do everything. If you can zoom out to the globe, the default for most software is it'll let you zoom out to the globe. How many of you ever had that experience where you're using a digital map and you did something stupid and you zoomed in so far you don't know where you are anymore and you're completely disoriented, and then you start panning and you're like, I don't know where I am, and oh, I think that's a railway, but I don't know what it is, and then you zoom out, and by this point you've now lost 30 seconds, which should have been a 3-second task. I blame 2 things there. I blame the software for letting you do that and not being smart enough to know that there are natural scale limits around data sets. Data don't have to exist at every geographic scale. And I blame the map author for not knowing better and for letting you, the reader, hang yourself with this ability to zoom in and out, when really all you needed to see were those 5 dots, on the Upper West Side said these would be good places to put the next Starbucks. So think about setting intelligent limits, technology that could look at your data and say, and we've done this and we've patented this, the algorithms that can say, based on your data, on a number of factors of your data, these are the scale ranges. You probably need about 3 zoom levels in order to see what you need to see in this data set. We set those as initial good defaults. The reason being, you can override them if you want. If you have some reason to let people zoom all the way out so they can see New Zealand, go for it. We're not going to stop you. But as a good default, as a starting place, it's really important to do that. Colors. How many of you choose colors if ever you've made a map just based on the aesthetics? I like blue, so I use blue. It's okay, we're among friends here, you can admit that that's how you do it. Very few of you probably have the background or training, I know I certainly wouldn't, to know how color theory should shape those decisions, how there's a lot of rules behind the use of color in thematic cartography, how, for example, here's a big one, your colors have to harmonize with the base map, right? And so you've got this sort of base information that's showing, because most of our maps have base maps. Another footnote, they don't all have to. How would you know what color schemes to use to make those things work well with the base map? Wouldn't it be great if your software was just smart enough to say, oh wait, you're using the light gray canvas base map, these are the 3 best color ramps to show this type of data on it. And therefore, you're not always getting the same defaults. A dumb default is something that is like my mission at Esri to kill. And a dumb default is it's always the same. Every time you use the software, it always gives you the same answer every time, regardless of your data, and more importantly, it never learns from you. Think about that. I could make 10,000 election maps with old school software, and it'll always give me the same. It'll never have learned from me and say, well, every time you make an election map, you tend to use a red scheme and a blue scheme because you're making a red map, blue map. No, I'm always going to start with a green color ramp because that's my default, right? And so every single time I have to undo it. And so think about technology that can look at you and learn from you and start to offer better choices, better defaults. Why do defaults matter? Does anyone know why defaults are so important and we're spending like crazy amounts of time on this? Everyone uses them. And when I mean everyone, I mean like 95% of the maps that we see made, and there are millions of maps that are made daily with our technology, people use the defaults. They either don't know to change, they don't know how to change, or they don't have the time to change. because they get something on the screen. How many of you use the default font in Word or the default font and colors in Excel? I know I just blast through Excel and I never think, well, I should format this in any way. The default's good enough for me. It looks like a spreadsheet, so I go with it. For most people, if it looks like a map and the colors are legible and the labels look okay, they just go with it. So nailing software defaults is an incredibly powerful thing. It empowers a lot of people because most of us have about 3 minutes to do our work and get on to the next thing in our inbox. So I know it doesn't sound very sexy, but trust me, defaults really influence a lot of people. And also, the other thing we want to do is invent, and I'll show you some examples of this, new ways to represent data, because the way you represent it changes the stories that you can tell, changes the understanding that you think you have of the world. This is an animation of the typical smart mapping workflow, and I did an animation because I knew I didn't have a lot of time and we could have spent the whole hour on this. But what I'm going to do is set up a couple things. As soon as we see the data, I can't even read what that is. It's some numeric attribute. And in fact, it's two. It's vote Republican and vote Democrat. We offer a gallery of choices. So if you notice, there's no pull downs, there's no ribbons, there's no menus. It's just simply visual. It says, well, given this data, these are different ways that you can represent this data. There's two numeric variables here, so number of Republican votes, number of Democrat votes. And it even ranks those based on the appropriateness of these representations. And so with one click, you can just quickly go down and say, well, what does it look like this? What does it look like this? How many of you ever had the experience where you click on something by accident in software, maybe you're working in Photoshop or something like that, and it wasn't what you intended to do, but it actually looks really cool, and it takes you down a really productive path, and you weren't even, you were like, I didn't even intend to do that, but it's so cool, I didn't start in that place. These galleries allow you with one click to try on like different jackets and see how they fit and say, well, that's not the story I want to tell. Let me try a different one. And if you don't feel like you're going to break it, then the likelihood that you're going to try new stuff is really, really high. So let's just watch. This is a video recorded. So I've got this. This was the default one, but I can try it as proportional circle with predominance as the color. I can do A versus B. I've just removed one of the variables now. Totally different list of gallery. You notice the base map changes and the colors for it. I'm getting in there now and I'm adjusting how the colors are applied. So there's a data distribution and the colors that are applied to it. I can go in here and change the thing that I'm mapping, and because I'm now mapping counts, it changes to proportional symbol because this is the most appropriate way if you asked a cartographer. Again, the same interface. If you can click and drag, you're ready to do smart mapping. Literally, you need to click and drag handles. That's it. I can tune the message of the map. I can, this is now getting super advanced here. I'm adjusting the transparency of the symbols by a second numeric measure. So the first, the size is the number of votes. The second, the transparency, is by a second numeric variable. And so again, the same interface, and you can see how some of them now fade away. This is a really powerful form of data focusing, which is different from data filtering. Data filtering is I'm not interested in it, just don't render it. The problem with that is you end up throwing away the baby with the bathwater, because there might be a lot of cool stuff in that data and a lot of subtlety that is lost if you simply say I'm only interested in X. So what I want to do is create techniques that can highlight the things that I'm interested in and diminish the things that I'm not interested in, but keep the data within its larger context. I can't tell you how important that is in data visualization. People say, well, I've got 1 billion data points, so I'm going to have to throw out 99% of them in order to make sense of this. That may be true, but be careful about what you're throwing away, because you may be missing literally the larger picture to understand what you're doing. And so really the era of the dumb default has to end. I want a conversation with my technology. I don't want a series of clicks. I always click button 1, then click button 2, then use this pull down, then click button 3. Data exploration is about empowering people with the least amount of work to find the maximum amount of value in their data. So if I can just find things quickly in 1 or 2 clicks, the chances of me doing it are very high. How many of you ever had that experience towards the end of the day, your inbox is still full, and you're like, I probably should go further with this data, I should probably normalize it, I know my training told me to do that, I just don't know where to find the data, I'm too tired, I want to get out of here, You just kind of be like, it's just too much work, it's physically too much work to have to do this. I'm not saying we're all lazy, but we've all been in that place, right, where it's like, this is just, I know on paper I probably should, I've been trained to do this, I just want software that can do it for you and can say, hey, it looks like you're mapping totals, I've taken the liberty of going and finding population data for you so you can divide your totals by number of people, right? I mean, can you imagine how cool it would be if your technology just offered that and just said, look, I think you could normalize this by area or normalize it by population. And then you'd be like, cool, if it's one click, I'll do it, of course, yes, normalize by population. You don't even know where to have to know where to find that data because you're part of an ecosystem that offers that data to you. So you just need to know how to like basically ride that wave. Big focus for smart mapping. We're about 2 years into that project now, as we've really moved on to multivariate mapping. This is where you want to map more than two things and code it into a single map symbol. So this is the kind of high-end professional cartography that really only experts were doing just a few years ago. It's the kind of thing that most novice map makers were like, I got colors and squares and I'm good. And like, no, you can actually go a lot further than that. And there's some very powerful techniques, especially within the context of data visualization. Here we have a map. The size of each symbol represents the count of the unemployed, and the colors represent the predicted growth rate of personal income. And so what you can do now is you can say, are there places that stand out here? Are there geographic patterns? Does the first law of geography apply here, that near places are more related than distant places? And you can start to drill in. Here's a second multivariate map where the thickness of the highway represents the volume of traffic, and the color represents the jurisdiction. So you can start to see maybe there should be coordination between the jurisdictions here in Florida to create better highway management, right? And so just adding that second piece of information, this isn't a second layer, you're encoding two pieces of information with a single map symbol. Let's go even further. This is thickness again of traffic, and color represents the degree of risk. Why does it make sense to add the terrain here to this highway map in Salt Lake City? If we're talking about risk from driving. Has anyone been to Salt Lake City? Anyone been up the mountains? All right, it gets cold up in the mountains. It gets snowy up in the mountains. Their mountain roads are twisty. So you could start to ask the question, based on terrain as perhaps an explanatory variable, am I seeing patterns where roads, even with low volume, tend to be very risky because of terrain? Because you might say, well, they're risky because they have a lot of cars, or they're risky because the terrain is really difficult. And so being able to juxtapose different data sets and ask these kinds of questions and start to explore. The other thing that I want to emphasize here is that you're almost never going to have that sort of magic bullet, like instant answer, like there it is, it's foolproof. These are ways to get into a problem. These are ways to quickly sketch out an idea and say, I wonder if, right? And that's a really powerful idea in data visualization. I wonder if, ... And so I wonder if there's a relationship. Well, then I can start to use formal spatial analysis tools to answer that question more formally and say, yeah, actually there was a 40% higher likelihood of accidents at higher elevation, blah, blah, blah. But this is my first pass at the data. Red state, blue state. We've all seen these maps. We're in the middle of elections, it seems, all the time. Really tired of these. What are some basic problems with this map? I mean, huge cartographic problems. Someone who doesn't know the United States, they would look at that and go, okay, yeah, that makes sense. Clearly red won by a landslide. This is actually Romney-Obama. Yeah. Doesn't take into consideration population. And so where people are, it's people who vote. It's not square miles. And so this map assumes that square miles are what count. It's not. It's people. So 1 million people in a city voting is much more important than 1,000 people in a giant county out in Wyoming voting. It just is, right? So that's another problem. What else is this map missing? Boundaries? It's only because of this terrible projector. Yeah, they're actually there. Yeah, sorry. What else? If I were running a political campaign and I would want to know where to spend my best campaign dollars, what am I not getting out of this map? Yeah. Exactly. You know, campaign managers don't spend money in places where they're going to lose 16-1. They spend money in places where it's like about 50-50, maybe 52-48. Those battleground states, those battleground counties, where you might actually be able to influence it. So there's no subtlety in this. And most of the world is not absolute black or white, one or the other. Most of the world is a mix of things. There's a lot of nuance in the real world. And our maps are overly reductive sometimes and miss that. Let's just zoom into North Dakota here. I really still don't understand the electoral geography of North Dakota based on this map. It's a terrible representation. So let me show you some work done by one of my colleagues, Jim Harries, who really looked at the, way more than you'd think you'd want to know, about the presidential election in North Dakota. This is a live story map, so you can go and check these out. These maps are live. So what this map is doing is it's showing you by white places that were 50-50, and the increasingly strong color becomes So if I click here, you can see that that was a pretty close race, but if I go here, you can see it's more than 3-1 in favor of Republican votes. And so this is called a predominance map because what it shows you is how strong the support is based on this. But we still have a problem here, and that is that geography out here, if you know North Dakota, not a whole lot of people live out here, right? They're cities still. And so what can we do to show that? Well, let's go here, and what we can do is redraw the election map as proportional symbols. And now the size of the circle tells you how many people voted, and the color tells you how strongly it went one way or the other. If it was truly 50-50, the circle would be white, because that's the tipping point. And so you can start to see really interesting geographies emerge here. And so this is just a much more realistic portrayal of the data than using the simple choropleth map. How many of you, though, I will pay you $10 if you can find an election map that doesn't use the base geography of counties or states as the way to tell the story? That's the worst way to tell the story. Use a cartogram, use proportional symbol, use something like this. Predominant education level. This is a really cool map. This shows us what is the most predominant degree. So this is taking numerical information and downgrading it to what is the most common degree in this location. And there are different, as you can see, there's a lot of high school. Let's see, let me bring the legend up here. That's the legend. And most places have high school. You can see the urban areas tend to have a little higher. But let's zoom in here. And you'll see that there are actually some real outliers here. Let's click on Arlington. And you can see by a long shot, the most common degree in Arlington is a graduate degree. A lot of people with master's degrees trying to make something of themselves in Arlington, hustling on the metro every morning. And it's interesting, so you're starting to see different patterns here. This is predominant education. The other way to do this would have just mapped these percentages, but instead saying, look, I'm interested in what is the most dominant characteristic of this place, highlight that for me, and tell me how much predominant it is, like how strongly predominant. Is it just slightly more than one or the other? What's this one? We'll skip that one. Make comparisons over time. This is another interesting map. This one shows, again, traffic in Washington, D.C., but the thickness of the line represents the total volume. Let's zoom in a bit. This is actually being run in the mobile mode. This is such a low resolution display. And you can see that they've compared two time periods. One of the things that we're interested in the real world is not just the state of something at this moment, but how has it changed, or what is its trajectory? And so if I were a traffic engineer, I'm trying to make traffic better in Washington, D.C. So I can see how much traffic, but the color tells me whether it's getting worse or better. This road, high volume, and it's getting better. So the green tells me it's going down. And so you can start to pull out different parts of the story that you might want to tell. This is a map, I think, relevant to some of the folks here in this room. It shows the most common age bracket that makes more than $200,000 a year. And what's interesting, let's close this. What's interesting is that the most predominant category in many parts, like down here, is actually the under 30 crowd. The largest group of people who make more than $200,000 a year in these neighborhoods are under 30. And so that's why this map was titled Young Money in Manhattan. So if you click here, you can see, again, we're running it in mobile mode. And so it's interesting. It's unexpected. You might ask why. What is going on right down there in that part of the city that you have more than half of the people who make more than 200 grand a year are under 30? What is it? Are they working in Wall Street? What are they doing? And this can lead to other questions. And so it's not that the map needs to be the final answer. It's that the map can be a place to start asking questions you didn't even know you needed to ask. Right, think about that. I didn't even know I needed to ask about people under 30 making a lot of money. Now I know I do. I'm interested in that. Tell me more. And if you have data that you can start to explore, then you can do really interesting things. Understanding change is a really, really important thing. One of the things that cartography has done for too long has been hung up on mapping static states. Think about the road atlases that you used as a child. Think about topographic maps. All of these things portray the world in an eternal and false present, as if nothing changes and everything is just as it is at this moment. Every map is out of date. The moment it is made, it is out of date. All data are old, right? And so this is why there's been such a revolution about the Internet of Things and sensor networks and crowdsourcing information and so on. But understanding change is really important. And so there are a couple of things, and this has been a big part of my research for the last 20 years. I did my dissertation on map animation and the cognitive strategies to help people understand change better and what we can do in our designs. Sometimes change, though, can be really, really simple. Just show me a line graph. This is 40,000 crimes in Washington, D.C. over a 1-year period broken out by major crime types, so like burglary, theft, homicide, and you can start to see questions like, well, is there a seasonality? And in fact, there is to some of these crimes. They definitely rise at certain times of year and fall at the other, and then you could do this over multiple time periods. This doesn't need to be animated. It doesn't need to be interactive. I don't need to zoom on this. It doesn't need to be 3D. I don't need to add drop shadows to these lines. You're just trying to understand the data, all right? So don't be seduced by, well, it needs to glow and it needs to move. It doesn't. I just need to say, can I get, and the other thing is I want to be able to actually get numbers off of this. And think about some of those sexy animations where you've got a 3D oblique pie chart. Good luck getting any numbers off of that thing. I mean, you're going to appreciate that they know how to use software, but you're not going to get numbers like 48%. And so I'm a grumpy old man when it comes to overly designed animations. Here's one that was not overly designed. And if you know Edward Tufte, you know he has this idea of data ink to information ratio. And this is a map, an example that achieves a data ink ratio of 1. Every single pixel on this screen communicates information. Nothing is extraneous. This was created by Aaron Koblin. Some of you may have seen this before. This thing was a real groundbreaking animation. I think he was still a master's student when he did this. He won an NSF, National Science Foundation award for data visualization with this. And what he did was he mapped all the flights. You see all the flights coming from Europe. You see how the East Coast lights up. Now the West Coast lights up as the time zone moves across the country. And you get to see these waves, these patterns. And so at any time, he's got 20, 30,000 dots on this map. And you'd think normally our gut reaction is that's too much to map. I can't see it. Another one of Tufte's principles here is the micro-macro principle. By seeing a lot of very small micro details, you get to see a large pattern emerge. So sometimes you need to thin your information to find the needle in the haystack. Sometimes you need to step back and see a much larger picture in order to see the patterns. And so this ability to map a lot of things at once. Watching the East Coast light up is a great example. All right, quiz time. Yeah?
Could you tell us what tool set you used?
I have absolutely no idea. Yeah, just Google search Aaron Koblin. This was a one-off boutique thing that probably took him 6 months. It's the kind of thing I'm actually really encouraging our community to get away from. These are kind of the boutique, high-end, I have a PhD and I have 6 months to work on it. The vast majority of us don't live in that world. We live and I've got 5 minutes and my boss is yelling for a PowerPoint. And so if I had 6 months to, I'm not taking anything away from it. In fact, for 15 years, that was my life. I was the guy who'd spend 6 months making beautiful animations. I've really come to a place where very few people have the luxury of doing that. And I really want software that can give me answers in 3 minutes or less. And if it can't, I don't have time for it. And so if I have to start messaging people on a message board, I don't know how to solve this one little weird thing and this thing, it's just, you're already now beyond me. It was great stuff. And it really, what I love about these pioneers though is they show us what's possible and they push that envelope of how far we could go with our technology. And then it's for folks like us who actually build tools that everyday citizens use to allow that to happen with a whole lot less work. All right, I know I've put some mental sorbet in there. How many of you remember anything about that flight animation? What time of day had the most number of flights? What time did most of the European flights land on the East Coast? 7-ish. You're kind of guessing, but it's really hard, right? You didn't remember. You got an overall picture of it, but you didn't remember a lot of it. And so although I am a proponent of map animation, and I have written many, many papers on this and done thousands of hours of research, it is great for certain types of map reading tasks. And it is terrible at others. If you need numbers, you need quantities, you need to compare A to B, and I have to watch A and then try to hold that in my short-term memory and watch a whole 1,000 other frames and then try to instantly capture B and then compare them and do the math in my head. Forget it. It's not the way to do it. There are other tools out there. And so one of the things that I've really been a proponent of for a long time is don't get hung up on one technique or one tool as if it's the thing. I'm really into animation right now, so everything's got to be animated. It's a terrible way to think as a data scientist. What you should think about is what are the strengths of animation, what kinds of things does it do well, what kinds of answers can it generate. Anything that I would ask you quantitatively about those flights, you'd probably struggle to do. You just can't remember it. Your visual memory's saturated. You remember the East Coast lit up because I called it out to you and things moved across. But it's very hard to get facts off of that. And so let me show you an example, though, where sometimes the less sexy option is actually the better one. So what I'm going to do is I'm going to log in and we'll just do some data analysis on some population change data. Signing into ArcGIS Online. If you have a browser and internet connection, you can do this work yourself right now. I'm using data that's publicly available through Esri. This is population data, demographic data. And this shows me the population of US counties. Well, let's get in here and actually start doing some lightweight data analysis. What I want to do is get in here and I can adjust various things here. Well, actually, let me just go back for a sec. Let's try this as proportional symbol. Why is this a terrible choice? It's great data. Why is this a terrible map? What it's telling me is Chicago is big. That's a whole lot of processing power to give me one piece of information. Relative to everywhere else, Cook County has a lot of people. Not a very informative data visualization. So sometimes it's not that proportional circles are terrible. They just weren't appropriate for that data and for that story. So let's go in here and we'll go in and we can adjust it. We can adjust the intervals here if we want. I'll zoom in. If we want a little more detail on this histogram, and I can adjust how the color gets applied, and yay, I'm still learning that big cities tend to have more people than rural areas. Not that interesting. What I want to do is calculate a change map, and so what I'm going to do is divide population 2012 by population 2010 to create a difference map. And so sometimes I'm not interested in the raw data, but I'm interested in the differences between time periods. And this is okay, it did it, but the problem is I'm still really having a hard time seeing a general pattern here. And it comes down to a very fundamental mistake that I made. I'm trying to show above and below as a high to low story. And so I've got the theme here, I don't know if you guys can read that, but if I go above or below and I use a diverging color ramp, I can now tell which places are growing and which places are losing people. The problem is that it's centered itself on the median, which is a little above 1, so let's center it on 1. And you notice, what does this tell us? Most counties grew over this 2-year time period, but only grew a very little bit. Now I can start to adjust the sliders if I want to focus in on certain areas and highlight certain things. What I can also do is very quickly, let's go back here. Let's go high to low. Tell me which county or which counties lost the most number of people in this 2-year time period? That's a totally legitimate question, right? It's something that I might want to know if I'm a governor or I'm a planner of some kind. So what county lost the most number of people? Can you find it here? You guys are going to have a really hard time. You're going to look and look and look and look. So it's not that a high to low color ramp is bad. It's just not going to help me in this task. But if I do this and then I grab this guy, what I can do is isolate. And you can see by just dragging it back and forth, do you see how the darkest counties up here jump out? And so it's this guy here, this guy here. These are the ones that are losing people. And so just being able to do interactivity and basic difference mapping can help you pull things out without having to like run analysis or, you know, it's a really basic question, what places changed the most. All right, well, let's go back to the demo. That's ArcGIS Online. It's live. You can just, if you haven't already used it, just go and use it. It gives you all of this data. We have 6,000 different demographic variables, so you don't have to go and find that data. More than that, there's then tens of thousands of volunteer data sets from authoritative sources in something called our Living Atlas. So if you want EPA data direct from the EPA, it's part of the Living Atlas. You don't need to go to the EPA website and look through some FTP site to find it. You can just, it's part of the Living Atlas and just say, look, I want to know about air quality in Los Angeles. Boom, it's right there. Oh, I want to know air quality for Los Angeles in 2010. Great, that's there as well. So just this ecosystem of data, it's two things. It's great tools and it's great data. And if you don't have either of them, you're really going to struggle, right? How many of you have thought, I've got the coolest question and I have no idea where to get the data to answer this question? And I've done that. I've come up with an idea where I've been like, this would be so neat if I could answer this. I don't know where to get the data. This is why we need to be part of an ecosystem where everyone shares content, authoritative content, open data. Open data is a big, big part of Esri right now, and will be for the foreseeable future. Data-driven styling. You remember I talked about how important it is that the software understand the data you're working with and offer the right choices? Let me give you an example of something that I worked on that was a pretty tough nut to crack. When we go to make a proportional symbol map, we have to decide how big to make the biggest circles and how small to make the small circles. When you ask a human cartographer how they do this, invariably the answer is, I do it until it looks right. I have about this much space, I have this many circles, I make the biggest ones just slightly bigger, just big enough to overlap. It's a very qualitative artistic process. That's cool. It's very hard to code until it looks right? Like that's our job as people who write software. We have to create algorithms that can mimic this. So we did, and based on different data, you can see here the California circle is the largest. It has just a little bit of overlap with that. The New York one is large. This was something we were really happy that we solved, was based on your data and based on the distribution of these circles, how big can the biggest ones get before they become too hard to read? This worked great. We were super happy with this. Yay. Then we zoomed out 2 zoom levels and we saw this. And then we went, boo, because suddenly our perfect algorithm doesn't work because it's being broken because it was a static solution on a dynamic map. And so what you need is a map that knows how to adjust drawing properties based on zoom level. And if it's done subtly, and if it's done well, absolutely no one notices. It just feels right. You're just like, well, okay, yeah, they're a little more congested, but I can still tell the overall story that I could tell 2 zoom levels in. Same here. This was the same, that first map zoomed in. You can't even see the symbols here. Look how tiny they are. I've zoomed in 2 levels here, and now they've lost. So what we have to do is fake it and make them a little bit larger so that you can see them. Cartographers have long been doing this. It's called perceptual scaling, but we're now doing it dynamically so that symbols can adjust the way they look so that you can see them and make sense of them. We also had to do things like set properties, any property of the map, the borders, the colors, the opacity, all of this stuff has to be automatically set. This looked great. We loved this. We thought this is great. Nice color scheme, works well with the dark light gray canvas. The borders look good. We zoomed out 3 zoom levels, and this is what I get. This map's a complete piece of crap. I would never put this in front of someone and say, there you go, there's my map, that's why you're paying me. You're not going to have a job tomorrow if this is the kind of map you think you can produce for money. So what you need is software that goes, okay, well, I can adjust the thickness of these lines so that I don't upstage the fill. Because remember, the fill is the actual data you're interested in, right? The color is the data. The borders are just, they're supporting cast, right? So they should be a supporting cast. We figured out how to do this not manually with someone deciding before publishing the map that at this zoom level the line should be this thick, and then at this zoom level they should be this thick, and then at this zoom level they should disappear entirely. We've been able to do that for a few years. It's great. How many of you have the time to do that? At every zoom level you have to author a new map, and then I author a new one here, and then I author a new one here. Now I've made 20 maps just so I can let you zoom in and out. What I'd rather do is author it once and have the software just say, I know how to draw it at every other zoom level based on this first zoom level. That's powerful, intuitive software, and we've done that, and you now end up with maps where you can see the counties here, and again, this is a crappy projector, but they're supporting information, and they know how to decrease what they're doing based on the other information. They know how to play nice. That's a huge breakthrough. Maps that are self-drawing is really important in a multi-scale world. The other reason why this matters is how many of you have ever tried to consume content on a phone or a tablet and it looks terrible, right? And so the display environment, the number of pixels you have to work with is really important too. And so all of this can be taken into account in terms of how these maps draw themselves. And if we've done our job well, no one will even know we've done anything. We have a whole set of color ramps that were professionally designed. These are multi-hue, perceptually graded color ramps that are very hard to create if you don't know what you're doing. They work well under reduced transparency, and they play nice with any of the Esri base maps. So we have these great base maps, that emphasize physical geography or transportation, or very simple like canvas maps. These color ramps automatically know which ones to use when, and they've harmonized. Things like this, when you have a light to dark color sequence to represent, say, a sequence of numbers, when it goes on a dark background, and if you notice many of the demo maps we've seen yesterday and today are all on dark backgrounds, most of you might not know that you're supposed to flip the ramp because the color with the highest contrast against the back should be the high. So in the old days, dark equals more in cartography. So the highest income has the strongest color. The highest life expectancy has the strongest color. That's on a white background. When you have a dark background, you need to flip it so that the other ones emerge. This looked terrible. Take my word for it. Another problem that we have is knowing at what scale to study and to ask the questions. If I ask the question, what is the population density of San Diego where I live? The answer is it depends on the geographic scale at which you're asking that question. If I ask that question at a county level, I'm going to get a very different answer than if I'm asking it at the block level. And so the answer that you get is driven by the geographic scale. This is one of the central ways that you can lie with maps. And I'm not trying to encourage you to do this. I'm asking you to be critical map readers the next time you see a map that says, look, we discovered something really strong, like a correlation between A and B. the first question you should ask is, at what geographic scale does that relationship exist? It may be very strongly correlated at the county level, and you go to a different geographic scale and that relationship falls apart. So it's not a very robust relationship, right? So you said there's a huge relationship between income and life expectancy. Is that true at every geographic scale? And if it isn't, should you be confident in making that claim? Should you be confident in saying to policymakers there's totally a relationship between income and life expectancy? I mean, there actually is, but you want to explore over what geographic scale do these things express themselves clearly. It's been hard in the past because we haven't had multi-scale maps that know how to do this, how to like show more and more detail on demand. But the fact that you can now run multi-scale analysis across all these different geographic scales, say, is it true at this geographic scale that those two things are correlated, or is it only true at higher geographic scales? So cartography in the 20th century, a lot got done. A lot of textbooks were written, a lot of courses got taught, and it's a great field. But it was almost exclusively focused on creating maps at a single scale. So when I print a map at 1 to 100,000, these are the rules that I should follow. 21st century cartography is all about creating data which knows how to render itself at multiple scales without any human input. And that is really one of the central research projects that I'm spearheading at Esri, is how do you create maps that are smart enough to say, based on all of these parameters, this is how I should be rendered. The reason why that's important is we no longer have the resources, the human resources, to author maps. People want maps instantly, they want them on demand, they want a map for an audience of one, right? This on-demand world. If you have to go and have a human intervene and say, whoa, 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 wait a sec, I need to get in there and adjust some of the dials to make the map look right, it's going to fail. So the more we can automate this, the more successful we can be. Scale-aware styling, data-driven defaults, they're not just buzzwords, they really are going to change the way in which you work with data and reduce the distance between raw data and seeing that data. Have you noticed over the years when you hear a lot of presenters speak, they'll show you the finished work, and then they'll pause for a second and step back and say, okay, now let me tell you, that was like a year's worth of headache to get it to that place. Anything we can do in any field to close that gap between raw data and really cool representations of the data is a win for everyone. All right, there's another project that I'm working on called Insights for ArcGIS. It's not yet public. It'll be coming out later in 2016, later this year. And it's really a fun project. It's a 1.0, and it was great to be brought in on this and to really think up the UI and the UX and kind of the overall experience of why we're creating this product. And it all revolved around a question that I posed to the team. If we could rethink GIS in 2016, if it did not yet exist, what should it look like? What should the workflow be like? What should the experience be? And the best answer we came up with is it should be a mix of geographic visualization, data visualization, where I can drag sliders and zoom in and out and substitute in different layers, very quickly, sort of very fluid workflows, where I'm sort of sketching ideas on a canvas, with the power and robustness of geographic analysis, so spatial statistics, and all sort of the deep analytical capabilities of traditional GIS. But all of that is running like an iceberg beneath this very smooth surface that offers very little friction and creates this really simple drag and drop experience. The other thing that we've done in this project to keep ourselves really focused is we said, if this thing had to run on an iPad, and only an iPad, what would the interface look like? Have any of you learned software on the desktop and then use the equivalent on the iPad? And it's totally different, right? There's no pull down, there's no mouse. I don't hover over something to get a tooltip. It's like the whole interface is different, right? Because they've had to rethink it. Basically, you've got tap, long tap, and tap and drag. Those are the three interactions you have, and that's it. Or maybe multi-gesture and this kind of thing. But it really forces you to really rethink the simplicity of it. And we just wanted to create Insights because we wanted to bring a lot of people into the experience of doing geographic information analysis without feeling intimidated by the interface, without feeling overwhelmed by thinking, actually I could probably do this. Very quickly, I'm going to try a live demo of this. This is live. This is a build that may or may not crash. We'll see. So I'm going to search for data. I can search anywhere, but I know there's some cool data as part of ArcGIS Online, GAS Chicago. This isn't content I created, but it's people have donated it. This is my colleague Jim Harry's. Lots of gas stations in Chicago, and I might want to map how they look and learn more about them. So of course, it's all card-based, and over here, if I open this up, I can see different content over here. Well, let's bring in price. So this is one of the variables I can map. I could filter it here if I wanted to, but I'm not going to. So let's go price. And then I just drag the data across, and I get this, what I call just-in-time interface. So just at the moment I want to do something, it springs to life and says, oh, hey, Mark, there are 3 things you could do right now. Do you want to create a map? Do you want to create a chart? Or do you want to show a table? Well, let's create a map. Again, we've seen this problem today, haven't we? Why is this a terrible visualization? First of all, there's too many gas stations, so there's too many circles, and they're all roughly charged the same. So there's not enough variation in the data to see anything interesting. Well, we can undo that and go back, and I can grab price, drag it across. Yeah. Like I said, it may break. We're working on this right now. All right, let's reload this. Yes. But I'm going to make a histogram out of it, and you can see that it's great because it's linking the cards together. And so I don't have to create these relationships. It's smart enough to create them for me. And so you'll see this in just a second. Gas prices, add, close. And this gets to that thing that I was saying earlier. There's no one magic bullet in data visualization. You can't say the map's always going to be better than a chart, or chart's always going to be better than a table. It depends on the question you want to ask. And in fact, it's sometimes these things playing together that's really, really important. So I will bring price over, and I will create a chart from that. And now I can focus the map and find different locations that are in this. I can also adjust the granularity of my data if I want more bins. I can do that. And you can see what you think you know about the distribution of gas prices changes just based on changing the histogram. Always question how certain you are about the thing you're claiming. Oh, clearly there's a normal distribution to gas prices in Chicago. Really? Dig a little deeper. See if that's actually true. Well, let's bring in brand as well. Let's go corporation here. So I know there's a lot of different corporations that sell. We can create a chart from this. And so now I can start to look at, well, where does 7-Eleven sell gas in the Chicagoland area? Well, they sell it all over, and they sell it across a full distribution of price. What about some of these retailers up here? You can see they tend to be a little more concentrated. Well, I can also group this by county, because I have a hypothesis that the county that the gas is sold in is one of the things that's powering these differences. So it may have explanatory power. So if we go county, I know this is a little hard to see. I can start to click on here, and I can see, okay, well, what does Shell charge? And you can see, yeah, absolutely. In Cook County, Shell charges more for its gas than it does in other counties. And so this idea that one representation leads to another, and lets me drill in through my data, bring in different data sets, represent it, visualize it in different ways. I can filter, I can do all sorts of things. The other thing, just the last thing I'll mention is, as I work through this, it's recording what I'm doing, and it's creating a knowledge model of my work. And so it's representing all of the steps that I do in this exploratory process so that I can save the model and share it with others who may want to hydrate it with their data. So I may be doing retail work in Chicago, but I want to share it with my colleague who does retail work on the West Coast and say, look, this model does a really good job of explaining this pattern or this process. Why don't you try it with your data? And so they can take my model, put their stuff into it, and I don't have to write down these steps. How many of you have ever done that, where you've forgotten to write down what you were doing, and you can't remember how, and you can't recreate it, right? You were like, oh, that was so cool. I got an answer that was so awesome, but I can't remember the 16 steps that it took me to get that answer. And so if you have tools that automatically record what you're doing while you're working, you can work at full speed and then look back and go, oh, that's how I got that answer. Okay. And then you might want to adjust it here because all of these are interactive. So let's say I did filtering in step number 2. I might want to remove the filter and rerun the analysis and see if it still holds up. So tools that kind of work with you, it's a really big theme for us. All right, well, let me just wrap up here and take some questions if we have time. If you want to learn more about smart mapping, esri.com/smartmapping, or email me. I'm happy to talk about all this stuff as one of the guys who really nerded out about smart mapping. And there's so much more to it than what I showed today. Really, I just had a chance to show you a couple ideas. Esri.com Insights, this is the product that's going to be released. It's those cards where you drag stuff in and they link together, and you can ask questions, you can do filtering, you can run analysis. There's actually some demo videos there if you want to get a sense on this page of kind of what it looks like in action. Another good resource, this is a project that I head up at Esri called Maps We Love, and it's a place to go and learn how to do some of these more advanced techniques. We hear from a lot of people, that map's so cool, I could never make that. Yeah, actually you can. It's like 4 steps. It's really not that hard, but if someone doesn't show you those 4 steps, you're never going to get there. So those are good resources. Feel free to email me if you want to learn anything more about this, if you want to see some of the examples, at least the things that are public facing that I can share right now. I'll happily do it. And that's it for now. Thanks, everyone. Questions? Yeah.
Thanks for the report. I'm interested in your kind of population change.
Right.
I'm working on a similar project and trying to indicate the kind of housing price change during the past 10 years in New York City. So I don't know, I have the kind of raw data and the kind of housing price change.
Yep.
How can I use my data to tap into your tool and to form some kind of
Yeah, a couple of ways. We have a couple of software products. You can use ArcGIS Online if you want to do this all in a browser, and you can upload like Excel files, CSV, something like that if you've got a spreadsheet of data. But really the tools are just as much as what you saw there. It's about as many steps as it would take. If you have prices per year, is that how your data is divided up? Housing prices per year?
Kind of 10 years.
Yeah, 10 years, yeah. And so do you want to notice the change from year 1 to year 10, or are you interested in the rate of change over those 10 years?
I just want to know the change from year 1 to year 10.
Oh, okay, so yeah, just a difference map like I did where you subtract one from the other, or you can map like the percentage change, whether it's up or down and how much it's up or down. Something like a proportional symbol map might be great if you want to call out certain areas that maybe have doubled in price. Those would look really dramatic. You could do a predominance map where the size of the circle tells you how much rent costs or how much the housing costs, and then the color of the circle could tell you how much it's changed. So if it's white, it maybe cost $1 million, but it was $1 million 10 years ago, and it's $1 million today. If it's a large circle, it's $1 million, but if it's dark red, that means it's actually doubled in price over the last 10 years. And so that way you can both get at the magnitude of the overall data, and the color can indicate the amount of change over a time period. So, and that would be 2 clicks to do in ArcGIS Online.
But the raw data is kind of regional level or commission level.
Okay.
For instance. So I don't know, at that kind of minor scale, can your tool fit into this?
Yeah, in fact, what you can do is you can use some of our tools to aggregate your data up. How many of you ever had this problem? This is a general problem. People will say, well, my data came as points. You know, they were individual crimes, and so I guess I just got to study them as individual points. That's complete BS. No, you might want to study them at the block level. You might want to aggregate your data up to a different geography. And tools that let you do that, both Insights and ArcGIS Online, allow you to aggregate your data up to a different spatial scale. So if, let's say, you really want to tell this using a different geographic unit, we run into this all the time where people say, well, one of my data sets were health service areas, and one of my data sets were counties, and they don't quite match up. And how do I bring these 2 data sets, because they're apples and oranges, and I can't just like add them together? There's some really great techniques that you can use to do this kind of like standardizing of your data to a certain geographic scale. And so yeah, it's totally doable what you're talking about. So if, let's say right now your data is too fine a geographic scale and you want to generalize it a little more, you can totally do that. Yeah, we can talk more afterwards. Yeah.
So I work with public health data, health information systems.
Yep.
And my question is that some of our variables change dynamically, but how do we dynamically hook our HIS application to variables such as, we work with great APIs to export data sets and upload them. How does that work?
Yeah, absolutely. I don't know if we're quite there yet, but you're absolutely right that with real-time data streams, which is a really big part of Esri, I don't work with that team, but these are, we have customers who have 1 billion transactions a second. So I mean, when I'm talking about large data, I mean, it's a mind-bogglingly large amount of data that they're working with. And they can't say, well, every morning I'm going to wake up and make a new map of my fresh data. They need the map just to generate itself and be updated constantly. And so yeah, that's totally possible, where you feed the information in and the map basically renders itself live. And you can even set like over what time period, like take the last hour of data and use that, and they just sort of have like this moving average that moves across time and is always the last hour of worth of data. I've not done that work, but it's totally doable, and it's where a lot of people are going because they want to set it up once and have it just run. And so, they may have like first responders in the field who want to bring this up on an iPad and say, oh, is that what the current weather conditions are? Or, whatever. I need the latest data. So, yeah, that's a big trend. That was another thing where I said, maps were very much about static, and I was talking about change over time, but we also have change moving forward, which is I now need to set it up and just let it run and just let it play and have more information come in. So, yeah.
So your solution is designed for cloud now.
Yeah.
And Google works through APIs.
Exactly. Yeah.
From our
Exactly. Yeah. It's I wouldn't know the technical details of how to do that, but I know it's doable, and I've seen it done. And so it is possible to ingest real-time data. Yeah, it's on the third floor in building. Yeah, most of those people. Yeah.
And Mark, you talked a lot about the user experience,
Yeah.
ease of creating smart mapping. There's also a trend towards the programmatic control of the dynamic web map.
Right.
Are we looking to do more of that as well, or expose APIs for higher cartographic work? Examples of that or samples?
Yeah, so just so I'm clear, you're saying where basically there's no human in the loop, no one dragging those sliders, but basically there's a set of rules that can operate behind the scenes, so the map is taking its orders from a program or from a data source rather than from a human saying, well, I want the color break to be here. Is that?
I've often asked about using third-party technologies.
Right.
Calling in the Esri stack as needed. Maybe using those cartographic capabilities inside other skins, other interfaces.
Yeah, absolutely. The great thing that the guys did when they ended up building all the smart mapping technology was they built it at the API level. So every single one of our apps calls that API and can make use of that logic. So you don't have to know the algorithms for thinning the lines. It can just do it itself. So basically we use our API the way our customers use our API. You can just call it and it will give you the answer that you need. And so this Insights project that I showed you actually doesn't have any of those map rendering stuff in it at all. It just knows to ask the smart mapping, the JS API for the right map result back, and it gives it those results. And so I've seen some of the other teams where they want to use smart mapping, but in a slightly different way. They kind of almost want to override our smart defaults and kind of do their own thing for a very specific reason, and they're able to do that as well. And so you're not sort of penned in to having to always use our smart defaults if you have a better reason to do something else. But yeah, exactly. That's the whole point of these APIs, is that you don't even have to know how the magic works. You just make the call and you get the right answer.
Are there samples, is there GitHub or anything, or do you anticipate doing that?
Yeah, absolutely. Let me get you an answer on who we could talk to get those examples. Again, I'm kind of the least technical guy working at a software company, so yeah. But I'll hook you up with the right people. Any other questions? Yeah.
I was interested in your concept about quitting your
Intent, yeah.
and just what's the behind that?
Yeah, that's a long-term vision for me. That's kind of like a statement that I put out there to kind of get people fired up at Esri and publicly. I think what we want more and more is to take the same approach that Google does when you use their search engine. I don't know at what point my searches just started getting crazy, and I just started typing these weird, long, semi-sentences. And even before I finished typing, Google's like, yeah, I think what you really want is this. And I'm like, how did you know? And basically what they're doing, and one of the things they're doing is, obviously machine learning and artificial intelligence, but they're also simply watching us and learning from us in aggregate. So when you have 1 billion searches, you can start to learn a lot about what we meant when we typed this. And so we have the same opportunity, because so many millions of these maps are public, that we can start to say, well, when it tends to have the word totals or dollars, we can see that 80% of the maps tend to look like this or tend to treat the data this way. And so it's just kind of learning from this large collection of work that's out there, that's publicly available, basically mining the publicly available maps and analysis that people have done. It doesn't sound nearly as sexy as intuiting our intent when I say it that way, but that's really basically what it is trying to make better guesses every day as to what you want, and offering those choices for you. The other thing that I want to mention that is really important, just like the Google search engine doesn't actually take any power away from you, even though it's auto-suggesting and say, did you really mean? I can still say, no, actually, it's not what I meant. I really did mean what I typed. You can do the same thing here. Smart mapping in no way disempowers you or says, well, you clearly don't know what you're doing, so let me take over. It's basically saying, look, let me just try to get you in the right ballpark. If it isn't correct, it's the same number of clicks for you to get what you wanted anyway. And so it's this idea of just trying to make a first best guess at what you wanted to do. That work we haven't really started in earnest yet, this kind of artificial intelligence, this sort of machine learning stuff that we can do. But I think that's going to be a really big area of growth, actually in a lot of areas, to be honest. I think, yeah, I won't say more about that, but it's a big area. Great, well, thank you, everyone. Have a wonderful afternoon.